Hello, my name is Chris Hickson, and this is my presentation of methods in teaching mathematics for Prescott College's Secondary Content Methods class. The two methods I'm going to be going over today are the direct instruction method as well as the constructivist method. The direct instruction method, otherwise known as the direct teaching model, is a model in which a teacher will present a skill set or an algorithm, and the students are expected to memorize through practice or through implementation the algorithm and where and when it needs to be applied. So this is also called the I do, we do, you do model, and the reason for that being at the beginning of the class, after the introduction and review, the teacher will provide model a skill that the students will be learning for the day, and the teacher will then provide one or more ways to solve this given problem using algorithms or predetermined methods. So one of the pros to this is that this does, I guess it could be a pro or a con depending on how you look at it, but it ensures trained responses from the students because they are going to be modeling exactly what you've shown them. One of the downsides, though, is that this teaches students to recall algorithms in order to solve things that they recognize. So if they recognize this as the circumference of a circle problem, they go to the file cabinet in their brain and immediately pull out the algorithm for the circumference of a circle problem. The issue with this is that firstly, we don't apply real-world scenarios to this very well, and when we don't do that, the students have less of a connection to what they're learning. When we don't connect the math curriculum to our community and their experiences and the students' prior knowledge, a lot of it can seem very foreign and alien. And so while they may be able to produce an answer to a given problem using a modeled algorithm, they may not necessarily be able to analyze the problem and give you a critical answer. So this model uses a tiered teacher support system. So in the beginning of the class, the teacher is responsible for all of the modeling. And this, again, is why it's called the I do, we do, you do model. And because after the teacher is done presenting the algorithm or the methods of solving the problem, it next moves to the classroom's responsibility. So now some of the responsibility is on the students as well as the teacher to solve the next example using the method the teacher has shown. After this, students will break out in groups or partners and demonstrate their ability to regurgitate the model that the teacher has shown. And lastly, there is a formal or informal assessment to determine if the student is able to do it themselves, is able to use the algorithm or method the teacher has provided. The second method I wanted to talk about is the constructivist method. And this is also called the inquiry-based method because students use their knowledge. They work to construct their own knowledge and their own understanding of the topics. They work using their shared experiences as a class to foster their own discovery of the skill and how they might solve it. And the theory behind this is that if students can make that discovery, when you then later show them the algorithm or whatever is widely assumed to be the most efficient way to solve the problem, they have a strong connection to that learning, and they can relate that better and recall it better. So this fosters the building of mathematical skill sets, but it also fosters community learning and social skill progression, which are both vital to student development. Now, the downsides to this are real. I mean, ultimately, at the end of the day, we are restricted to how long we have the students. We don't get them all day long in secondary mathematics courses, so we are limited to how often we see them. But if we use the discovery method, the inquiry-based method, to foster a child's sense of connection to mathematics, they may begin to see that in other places in the math classroom, which I think is ultimately the goal. In addition to being time restricted, this method can be unpredictable. And what I mean by that is that when you have students working on self-discovery, their discoveries or their outcomes can vary widely in compared to the direct teaching method, where they're just modeling the teacher's methods. In this teaching method, in the inquiry-based teaching method, the students are developing their own sense of solving the problem, and so their outcomes can be very different. And so this requires a teacher to have a very strong understanding of the content and an attuned ability to predict where the students might go with it. Regardless of which method you decide to use or what combination, because ultimately I do believe that there are opportunities to use the direct teaching model and opportunities to use the inquiry-based method. But no matter which one you choose or any combination, research has shown that it's very important in mathematics to provide real-world scenarios. And this kind of piggybacks on the intent of the inquiry-based method, but it is important to relate student experiences to what they're learning. If we can get these students to realize that mathematics affects them in their everyday life, they may be able to build stronger connections to those mathematical skills. Additionally, mathematics, at its core, and using algorithms and writing proofs can be very abstract, and so fostering concrete connections for students helps make that abstract idea concrete. This is a more widely debated topic, but I believe that it's important to apply real-world limitations to problems. So for example, if we have a fish tank and we're trying to figure out how many fish this tank can support, and the students decide that it can support 15.4 fish, while some teachers or some researchers would argue that 15.4 is the correct answer, others believe that this is only the mathematical answer, and while the mathematical answer is correct, it's wrong in the sense that we're not applying the real-world limitations of the scenario we're in. There's no way of putting 4/10 of a fish into a fish tank. And so having students be more critical in their answers again fosters those concrete connections. And it's important that students see math as something that is used in the real world and not an abstract or foreign language. But again, one of the downsides to this is that it does require the teachers to be more familiar with the content. In order to apply the real-world limitations or the real-world laws that we all are faced with, you must have a strong understanding of what's happening with the math. Additionally, there are researchers and teachers that feel that this can detract from a clear understanding of the skills. So what I mean by that is when they're learning to apply the Pythagorean theorem, if we model too many real-world scenarios, some researchers feel that students will have a harder time memorizing and being able to recall the actual Pythagorean theorem. Additionally, one of the downsides to this is, again, it's limited by the time we are with the students. Another useful tool to use when applying either the direct instruction or inquiry-based method when teaching mathematics is to spiral teach. Because mathematics is sort of like a brick wall in that you build it from the ground up, layer by layer, it's important to come back and reinforce the foundation or the previous layer. Because if the previous layer becomes weak, just like in a wall, the wall may not hold. And so in order for us to build on these old concepts, this old content, we must make sure that the students have maintained that content. And this can be implemented in different ways. You can implement this in bell work, in review problems or review quizzes. You can even implement this in your lessons. You can find ways to implement the previous lesson at least slightly into your current lesson, and that not only allows students to continue to build on their mathematical content, but it allows them to refresh their memory on what they've already learned. So that's my presentation in teaching mathematics using different methods. I hope you enjoyed it. Thank you very much.